Now that we know more about the complexity of our data after exploring with it, we'll talk about pre-processing data or transforming it to make it ready for analysis. After this video, you will be able to identify some problems with real-world data and describe what is needed to transform raw data to data that can be used for analysis. The raw data that you get directly from your sources are never in the format that you need to perform analysis on. There are two main goals in the data preprocessing step. The first is to clean the data to address data quality issues. The second is to transform the data to make it suitable for analysis. A very important part of data preparation is to address quality issues in your data. Real-world data is messy. There are many examples of quality issues with data from real applications, including inconsistent data, like a customer with two different addresses recorded at two different sales locations, but these recordings don't agree, or missing customer age in demographic studies, or an invalid zip code, for example, a 6-digit zip code, and outliers, like a sensor failure that causes values to be much higher or lower than expected for a period of time. Since we get the data downstream, we usually have little control over how the data is collected. Preventing data quality problems as the data is being collected is often not an option. So we have the data that we get, and we have to address quality issues by detecting and correcting them. Here are some approaches we can take to address these data quality issues. We can remove the data records with missing values. We can merge duplicate records. This would require a way to determine how to resolve conflicting values. Perhaps it makes sense to retain the newer value whenever there is a conflict. For invalid values, a best estimate for a reasonable value can be used as a replacement. For example, a missing age value for an employee can be filled in based on a reasonable estimate on the employee's length of employment. Outliers can also be removed if they are not important to the task. In order to address all these data quality issues effectively, knowledge about the application, such as how the data was collected, the user population, the intended uses of the application, etc., are important. This domain knowledge is essential to making informed decisions on how to handle incomplete or incorrect data. You also need to be careful about the changes you make to avoid coming to incorrect conclusions, and be sure to keep records of the changes you make. The second part of preparing data is to manipulate the clean data into a format needed for analysis. This step is known by many names: data manipulation, data preprocessing, data wrangling, and probably my favorite, data munging. Some operations for this data munging, wrangling, preprocessing include scaling, transformation, feature selection, dimensionality reduction, and data manipulation. Let's look at these in further detail. Scaling involves changing range of values to be between a specified range, such as from 0 to 1. This is done to avoid having certain features with large values from dominating the results. For example, in analyzing data with height and weight, the magnitude of the weight values is much greater than the magnitude of the height values. So, scaling all values to be between 0 and 1 will equalize contributions from both height and weight features. Various transformations can be performed on the data to reduce noise and variability. One such transformation is called aggregation. Aggregate data generally results in data with less variability, which may help with the analysis in the long term. For example, daily sales figures may have many spurious changes. Aggregating values to weekly or monthly sales figures will result in smoother data. Other filtering techniques can also be used to remove variability in the data. Of course, this comes at the cost of less detailed data, so these factors must be weighed for the specific application. Feature selection can involve removing redundant or irrelevant features, combining features, and creating new features. During the exploring data step, you may have discovered that two features are very correlated. In that case, one of these features can be removed without negatively affecting the analysis results. For example, the purchase price of a product and the amount of sales tax paid are likely to be very correlated. Eliminating the sales tax amount, then, will be beneficial. Removing redundant or irrelevant features will make the subsequent analysis simpler. In other cases, you may want to combine features or create new ones. For example, adding applicant's education level as a feature to a loan approval application would make sense. There are also algorithms to automatically determine the most relevant features based on various mathematical properties. Dimensionality reduction is useful when the dataset has a large number of dimensions. It involves finding a smaller subset of dimensions that captures most of the variation in the data. This reduces the dimensions of the data while eliminating irrelevant features and makes analysis simpler. A technique commonly used for dimensionality reduction is called principal component analysis. Raw data often has to be manipulated to be in the correct format for the analysis. For example, from samples recording daily changes in stock prices, we may want to capture the price changes for a particular market segment, for example, real estate or healthcare. This would require determining which stocks belong to which market segment, grouping them together, and perhaps computing the mean, range, and standard deviation for each group. In summary, data preparation is a very important part of the data science process. In fact, this is where you will spend most of your time on any data science effort. It can be a tedious process, but it is a crucial step. Always remember, when it comes to data processing, garbage in is garbage out. If you do not spend the time and effort to create good data for the analysis, you will not get good results, no matter how sophisticated your data analysis techniques are.